Hi students, have a nice day. Let's continue the properties of alkenes. In the last section we discussed about the Markovnikov's rule. So today we are going to discuss about the mechanism of Markovnikov's rule and anti-Markovnikov's rule. What is Markovnikov's rule? When an unsymmetrical addendum adds to unsymmetrical alkene, the negative part of the addendum get attached to carbon contains less number of hydrogen atom, or carbon possesses less number of hydrogen atom. First of all, we discuss the mechanism of Markovnikov's rule. In that we take propene and HBr. Okay, propene and HBr. So CH3, CH double bond CH2 plus HBr gives CH3, CHBr, CH3. This is the major product according to the Markovnikov's rule. Plus CH3, CH2, CH2, Br. 1 bromo propane is minor product, 2 bromo propane is major product. And the mechanism, what is mechanism? The step in which the reaction follows, the path in which the reaction follows. In the first step, HBr undergo heterolytic fission and forms an electrophile H plus and Br minus, that is nucleophile. So this is electrophile E plus, this one is nucleophile Nu minus. And the second step, this electrophile is added to alkene. Okay, the electrophile is added to alkene. And we get carbocation. So CH3, CH double bond CH2 plus H plus. Okay. And we get 2 intermediate carbocation. 2 intermediate carbocation. First one is this hydrogen is added to this carbon atom. We get CH3, CH plus CH3. Remember that this electrophile get attached to this carbon, first carbon. We get isopropyl carbocation. That is a secondary carbocation. Secondary carbocation. Isopropyl carbocation. Another possibility is this electrophile get attached to second carbon atom. So what we get? CH3, CH2, CH2 plus. This is a primary carbocation. This one is a primary carbocation. Which carbocation is more stable? You know that secondary carbocation is more stable than primary carbocation. Which one is more stable? Secondary. Out of these two, correct order is tertiary greater than secondary greater than primary. So here in this case, secondary carbocation is more stable than primary carbocation. And that's why the composition of secondary carbocation is more. And the third step, the addition of nucleophile. The nucleophile get attached to the carbocation. We get 2 products, CH3, CH2, CHBr. Okay, the Br is added to this carbocation. Okay, I will write the step. Okay, I write as a step. CH3, CH plus CH3, Br minus, we get CH3, CH, Br, CH3 as a major product. Okay, this is more stable carbocation. That's why this product is a major product. And when Br minus is added to CH3, CH2, CH2 plus, we get 1 bromopropane, CH2, CH2 plus, Br minus, we get CH3, CH2, CH2, Br as a minor product. Why it is a minor product? Less stable carbocation, and from the less stable carbocation we get 1 bromopropane. So major product is 2 bromopropane, minor product is 1 bromopropane. This is the mechanism of Markovnikov's rule. So Markovnikov's rule follows electrophilic addition. Okay, remember that Markovnikov's rule follows electrophilic addition. First electrophile is added to the alkenes. A very important thing. It's usually asking in the board exam as well as competitive examination. Next year also, plus 2 also, this mechanism comes. Okay, in that chapter, teacher tells, already you know the mechanism, refer class 11. Okay, this is the mechanism of Markovnikov's rule. And we move to the mechanism of anti-Markovnik addition or peroxide effect or Karash effect. Okay. Then in the case of anti-Markovnik addition, the addition takes place in the reverse order. We get 1 bromopropane as a major product and 2 bromopropane as a minor product. Okay, let's check what happens. Okay, we will discuss what happened in the anti-Markovnik addition. In anti-Markovnik addition, in the case of anti-Markovnik addition, the peroxide will create free radicals. Okay, the peroxide will create free radicals. That free radical addition takes place in the anti-Markovnik addition. Okay, free radical addition. Yes, then we discuss anti-Markovnik addition. Anti-Markovnik addition. In that, a peroxide, organic peroxide, C6H5COO twice. It is also written as C6H5CO twice O2. Both are correct. Up to this twice, then oxygen 2 times. Okay. The first step, formation of free radical. So C6H5C double bond O, C double bond O, C6H5 undergo homolytic fission, homolysis. Okay, homolytic fission. What we get? 2 moles of C6H5 C double bond O free radical. Okay, benzoyl free radical, benzoyl peroxide, benzoyl free radical, and that free radical gives 2 C6H5 free radical plus 2 CO2. Okay, remember that. This free radical decomposes gives phenyl free radical plus carbon dioxide. And this phenyl free radical, okay, in the second step, the phenyl free radical C6H5 plus HBr. Here also homolysis. Okay, homolysis takes place. We get benzene C6H6 plus Br free radical. A very simple step. Please listen. It's a very important. Benzoyl peroxide undergo homolysis. Okay, homolysis. We get benzoyl free radical. Then decomposes gives phenyl free radical and carbon dioxide. Carbon dioxide is a gas. Thus, the phenyl free radical comes to attack or it will react to HBr means C6H6 benzene and bromine free radical. Next is this bromine free radical added to the alkene. Okay. CH3 CH double bond CH2. Bromine free radical is added. Br free radical. Homolysis takes place. Homolysis. Okay. Comes into this area. Free electron. So homolysis will make two free radicals. Two alkyl free radicals. One is CH free radical, CH3 CH free radical, then a CH2 Br. This is one possibility. Okay, this bromine free radical is added to this carbon atom. We get CH3, CH free radical, CH2 Br. Are you clear? Yes. Another possibility, this free radical is attached to this carbon atom, second carbon atom. We get CH3, CHBr, CH2 free radical. Which is more stable? You know that this is secondary free radical, which is more stable. And this is primary free radical, less stable. Okay. Secondary free radical, primary free radical. Are you clear? So this is more stable. Why? Due to hyperconjugation and inductive effect, tertiary free radical is more stable than secondary free radical is more stable than primary free radicals. And finally, to this free radical, HBr is again added. Okay, so here is no space. I just erase the first two steps. So into this alkyl free radicals, HBr is again added. So CH3, CH free radical, CH2Br plus HBr. What we get? CH3, CH2, CH2Br. Major products. Okay, first we take this free radical and add HBr, major products, 81%. Because this free radical is more stable. And another possibility, CH3, CHBr, CH2 free radical plus HBr, again homolysis. Okay, homolysis takes place. We get CH3, CHBr, CH3 as a minor product. Okay, minor product. So anti-Markovnikov addition is free radical mechanism. Okay, anti-Markovnikov addition is free radical mechanism. The Markovnikov addition is electrophilic addition. That's the difference. And Markovnikov addition, the negative part goes to carbon, contains or possesses less number of hydrogen atom. Anti-Markovnikov addition or anti-Markovnikov rule, the negative part goes to carbon contains or carbon possesses more number of hydrogen atom. Okay? Yes, next we discuss addition of sulfuric acid into alkene. Cold concentrated sulfuric acid adds to alkene. According to the Markovnikov's rule, alkyl hydrogen sulfate is formed. Okay, cold concentrated sulfuric acid added to alkene, we get alkyl hydrogen sulfate according to the Markovnikov. Okay, you remember that according to the Markovnikov, one product is major product and the other product is minor product. In organic chemistry, we consider the major products. Okay, yes. Let's discuss the addition. CH2 double bond CH2 sulfuric acid. It is written as HOS double bond O double bond OH. Okay, it is sulfuric acid. H2SO4. And we get CH3 CH2O. Okay, this hydrogen moves to one carbon atom and O group is attached to the other carbon O. SO2, these two oxygen is condensed and OH. Or we can write that CH3 CH2 HSO4. That's why it is called ethyl hydrogen sulfate. Okay, why it is called alkyl hydrogen sulfate? After addition, we condense the formula. Okay, CH3, CH2O, SO2, OH is the correct one, and we condense it into CH3, CH2, HSO4. The name is ethyl hydrogen sulfate. Then another alkene CH3, CH double bond CH2 plus HO, then shortly written as SO2OH. Okay, this formula we write here. HO, then SO2 is condensed, then OH. What happens? H2 plus and O, SO2OH is formed. Okay, this is plus, this one is minus. And the alkene is unsymmetrical. Here the alkene is symmetrical. Here the alkene is unsymmetrical. So negative part, this is the negative part. Okay, after breaking the bond, H2 plus and SO4 H minus formed. So the negative part get attached to carbon possess lesser number of hydrogen atom. This is isopropyl hydrogen sulfate. Okay, isopropyl hydrogen sulfate. Isopropyl hydrogen sulfate. And this is the major product. What is the minor product? Minor product is this species get attached to carbon with a or carbon possess large number of hydrogen atoms. So the minor product is CH3, CH2, CH2, O, SO3H. Or you can write HSO4. No problem. HSO4. It is N-propyl hydrogen sulfate. Okay, are you clear? Yes, this is the addition of called concentrated sulfuric acid into alkene. And next we consider the addition of water in the presence of acidic medium or in the presence of acids. So in the presence of acid, alkene gives alcohols. Okay, alkene gives alcohols. Let's discuss one or two examples. CH3 double bond CH double bond CH2 plus water HOH, and it is also according to the Markovnikov addition. Okay, according to the Markovnikov addition, CH3 CH double bond CH2 plus H2O. Okay, in your textbook it is written as H2O. H2O I write HOH to understand easily. So in the presence of an acid, H2SO4, usually we are taking H2SO4. What happens? This H plus OH minus. Okay, in water, H plus and OH minus. Negative part get attached to carbon with a less number of, or carbon possesses less number of hydrogen atoms. So what we get? CH3, CHOH, CH3 as a major product. As a major product. Plus CH3, CH2, CH2OH as a minor product. Propan 2-ol, propan 2-ol, propan 1-ol. Okay, propan 2-ol as well as propan 1-ol. So this is also according to the Markovnikov addition. And in the case of symmetrical alkene, only one product is formed. Ethene. Okay, this is propene, this one is ethene. H2O. H2O is written as HOH. And H plus OH minus. Okay, water is polar. In the presence of sulfuric acid, it gives H plus and OH minus. Okay, then that gives in the presence of acid. You remember that acidic medium is represented by H plus, or you can write H2SO4 in the acidic medium. What we get here also acidic medium. You understand that it is sulfuric acid. Okay, then we get only one product because the alkene is symmetrical. This OH minus add to any of the carbon atom or either carbon atom, we get only one product. If the OH attached to this carbon, ethanol. If the OH attached to this carbon, the molecule is saying ethanol. Okay, are you clear? Yes. Then next is oxidation. What is oxidation? Oxidation is addition of oxygen. Addition of oxygen. So oxidation carried out aqueous solution as well as in acidic medium. First of all, we discuss the oxidation of alkene by using dilute aqueous KMnO4. KMnO4 is a good oxidizing agent. KMnO4, K2Cr2, O7, HNO3, all these are oxidizing agents. Okay, so called aqueous KMnO4, dilute KMnO4, which is also known as Bayer's reagent. First of all, we discuss the addition of Bayer's reagent. Bayer's reagent. What is Bayer's reagent? Dilute aqueous KMnO4. Dilute aqueous KMnO4. Okay, when Bayer's reagent adds to alkene, okay, adds to alkene, oxidation, an aqueous solution, which means in the presence of water, we get CH2OH, CH2OH. What is it? Vicinal group. Functional group on the adjacent carbon atom, it is called a vicinal. So vicinal glycols are formed. Vicinal glycols are formed. What is the name of this compound? Ethane 1,2 diol. Ethane 1,2 diol. Are you clear? Yes. Then when propene is taken, CH3, CH double bond, CH2. Okay, when propene is taken, oxidation. Oxidation means dilute KMnO4. Dilute means it contains water. When it is treated with a dilute, here also the same thing. Okay, I write all. So O means the oxygen from the KMnO4. You can write here dilute aqueous. Dilute aqueous KMnO4. Dilute KMnO4 is enough because dilution is usually done by adding water. Okay, so dilute KMnO4 we get CH3. Okay, OH group attached to two carbon atom OH, CH2OH. This is glycols. Okay, glycols. So what are glycols? Glycols are the molecule having two OH group. And vicinal glycol means the OH group is on the adjacent carbon atom. So this is oxidation by using dilute aqueous KMnO4, also known as Bayer's reagent. And it is used as a test for alkene. Test for alkene. How it is a test for alkene? You know that KMnO4, dilute KMnO4, pink in nature, pink color. When this reaction takes place, the pink color disappears. Okay, a pink color very dilute solution which has pink color. So when we add Bayer's reagent into a compound, the disappearance of pink color means it contains unsaturation, or it contains double bond or triple bond. So it is also a test for alkene. Okay, one more test we discussed in the last section. Bromine water or Br2 in CCl4. Here also reddish brown color or reddish orange color disappearance, presence of double bond. Okay, here it is Bayer's reagent. The decolorization means the reaction takes place, and the alkene undergo oxidation, we get vicinal glycols. Okay, remember that. Next is oxidation by using acidic medium, or oxidation can be done in acidic medium. So acidified KMnO4 or K2Cr2O7 is used. We get different products, usually ketones or carboxylic acids. Depends upon the structure of alkene. So depends upon the structure of alkene, we get different products when we are using acid KMnO4 as an oxidizing agent. Okay, let's discuss. CH3 twice C double bond CH2. Okay, CH3 twice double bond CH2. When we are using KMnO4 in acidic medium usually represented by H+. Or in examination the question is asking like this, nascent oxygen, that means oxidation. Or so oxidation takes place, the bond breaks here, C double bond O, CH3, CH3. Okay, are you clear? Okay, write into skeletal form. We get CH3, C double bond O, CH3. Why? CH3 twice. CH3 twice. So CH3, CH3. See, oxygen is added to this bond, C. Plus this oxygen converted into carbon dioxide plus hydrogen converted into H2O. But we take the CH3, CH double bond, CH, CH3. Butene. Okay, butadiene. And KMnO4 in the presence of H+. KMnO4 in the presence of H+. We get the bond breaks here. Oxidation takes place. We get 2 moles of CH3COOH. Okay, CH3COOH. So depends upon the structure of alkene. Okay, depends upon the structure of alkene, we get different products. That's a very important thing. Okay, if the structure is like this, we get ketone and carbon dioxide. Okay, here one more CH3 is there. CH3, we get acid. Okay, so depends upon the structure, we get different products. You remember that. Okay, next is polymerization. Polymerization of alkene. I think you heard about polymers. Okay, polythene, polypropylene, polystyrene, etc. So alkenes undergo polymerization, we get polymers. Okay, so polymers are very useful substances in our day-to-day life. Polyethylene is used for making hoses, toys, bottles, etc. Okay, and also these polymers are used to make utensils, insulating, okay, electrical wire insulating, etc. Let's take one or two examples. First of all, polymerization of ethene. Polymerization of ethene. CH2 double bond CH2. It undergoes polymerization. Polymerization in the presence of a peroxide. Okay, we get CH2 n times. When we take n molecules of CH2, double bond CH2, we get CH2 n times. It is polyethylene. Polyethylene. Similarly, you can take propene, CH. Okay, propene is written like this. Polymerization, we get CH3, CH2 n times. Polypropene. Okay, are you clear? Yes. And the last topic in alkene is ozonolysis. A very simple topic. Ozonolysis. So alkene undergo ozonolysis, we get ozonide. On hydrolysis, we get different products. Okay. Okay, are you clear about this? Next is ozonolysis. Ozonolysis. The last topic is ozonolysis. So let's write the general equation. By studying the general equation, we can understand any reaction. First of all, O3. Okay, react with the O3, we get ozonide. Okay, very simple. Ozonide, oxygen C. This is ozonide. Okay, this ozonide is treated with the water in the presence of zinc dust, zinc powder. Okay, zinc dust. The bond breaks like this, and H2O takes the oxygen, that will give H2O2. A very simple mechanism, and we get C. The bond comes to this side, C double bond O, 2 valencies, plus this side also C double bond O, then we can write O double bond C, 2 valencies. Okay, this is the general equation, a very simple mechanism. Ozone is added to double bonds. Alkene, we get ozonide. Okay, a bridged oxygen, and another bridge comes, a peroxide link comes in between the carbon, COOC. Here is COC. And when we heated or boil with the water and the zinc dust, zinc powder, the bond breaks like this. Okay, the oxygen taken by water, it becomes H2O2. And bond breaks, this bond breaks, the bond comes here, C double bond O. And this bond comes here, C double bond O. And two valencies are there. Okay, a very simple example. First of all, we have to discuss a very simple example. Ethene, CH2 double bond CH2. Okay, H. First of all, we treated with the O3. Okay, O3. What we get? HCHOC. Oxygen, then two bonds. Then water in presence of zinc dust, heat. Okay, the bond breaks like this. We get HC double bond OH. That is HC double bond OH. Okay, HC double bond OH. Here also HC double bond OH. So two molecules of formaldehyde or methanol is formed. Two molecules of formaldehyde or methanol is formed. Similarly, you can take many alkenes. Okay, different alkene gives different products. And one more important information. If the alkene is symmetrical, we get on 2 moles of same product. When the alkene is symmetrical, we get 2 moles of same product. And if the alkene is different, we get 2 different products. Okay, so you practice more examples. And in the next section, we will discuss another topic, alkydes. Any doubt you can ask to me. Thank you.